I'm Christy Chamberlain, and I spent my summer researching at Scripps Institution of Oceanography. Here at Scripps, we do a lot of research, from getting ocean samples through surfing to investigating the wildfires. And here, we're at the Scripps Pier. Come on! Aw man, I wish I knew someone around here who could show me around the Scripps Institution. Is that Steve Diggs?
Yes, it is.
Steve!
Hi.
Christy, nice to meet you.
Hi, Christy.
What do you do here at the University of California?
Well, for the University of California, I'm their Senior Research Data Specialist.
That's awesome. Do you think you can show me around Scripps Institution?
Of course, come on.
Scripps Institute of Oceanography was founded in 1903 by a zoologist and philanthropist, Ellen Scripps, and her brother. It began as the Marine Biological Association to study marine life and has since developed into a whole lot more. Today, Scripps is home to many different types of research, falling within four main categories being Earth, Ocean and Atmosphere, and Biology. Projects revolving around climate change, aerosols, geophysics, ecology, and more are all being conducted here at Scripps. Famous researchers can be found on Scripps campus, like Ralph Keeling, son of Charles Keeling, who created the Keeling curve, the longest record of atmospheric CO2 concentration, or Jen Smith, an ecologist making groundbreaking discoveries revolving seaweed and its effects on methane emissions. Steve Diggs showed us that Scripps had a lot to offer, but the best of Scripps was waiting just behind a single door.
Oh, hi. I didn't see you there. I'm Stuart Sandin.
Dr. Sandin is the lead researcher of the 100 Island Challenge, an ongoing research project where 100 islands along the Pacific, Caribbean, and Indian Ocean are being recorded through data collection and digital imaging. The purpose of this research is to create an ongoing interactive coral reef database. Through scuba diving, large area imaging is being conducted at these 100 islands by using structure for motion photogrammetry. These images are then being uploaded to create vivid, interactive 3D models of each coral reef. This research, in addition to creating a universal database, educates communities around the globe to use large area imaging for their own research. Dr. Sandin research helps provide exploratory software to communities all over the world, allowing researchers to pursue off-site research with on-site data. Images of the 100 islands has been collected from the past 10 years, working to create the largest coral reef database. Data compilation videos, as the one seen here, helps the public easily observe how the corals on each island are changing and adapting over the years. This is just one of many ways the data has been used.
Action.
My research team here at Scripps Institute of Oceanography has been working to understand the variability of coral reefs on the planet. We're really interested in those coastal ecosystems because of the changes that are happening across the globe. One of the opportunities we saw was to study the variation from geography to geography to think about what is changing, how are reefs changing, and how could they face tomorrow.
Action.
The study of ecology is a tough field today. Most of the things we hear about tend to be stories of loss, of despair, of humans having a negative impact in the environment around us. A lot of that's especially true in the ocean. The ocean stories we see in the news oftentimes are the stories of decline. Coral reefs are probably one of those poster children, an ecosystem where every time we hear about it, we talk about a dramatic decline, some heroic loss. But that's not the way that the world's oceans are working everywhere. There are successes in addition to some of these heavily publicized problems. The research we're doing is trying to unveil what's actually happening with coral reefs, to try to understand some of that variation, both in space and then how things are changing in time. And with that provides us some true vision of what's happening. If we know that there are successes, and if we know that there's opportunity to manage for a tomorrow where reefs grow, that provides an opportunity for us to take management steps going forward. I think this is particularly true for the young generation. Being told stories of despair only leads us to more despair. But if we see that the despair is linked with opportunity, I think most people are going to try to find the opportunities and to try to build in that direction.
And action.
Mathematics is probably the field that is most undervalued across the natural sciences. Very often we think about the natural scientists, people get into the field because they're really interested in birds, bugs, bees. They like studying the natural history around them. They don't realize that the entire discipline is founded on mathematical descriptions of the nature around us. This could be anything from measuring the geometry of a wing through to thinking about the statistical properties of populations. It's fundamentally important that we describe and that we report what we learn about nature in quantitative terms. We have to emphasize mathematical education. We have to start thinking about your tomorrow will always include math, whether you become an accountant, biologist, or a coral reef scientist. So take your math class. So take your math class. So take your math class.